I'd like to begin by talking a little bit about NIST because I find people don't really know who we are and what it is we do. NIST is a fairly small agency that's part of the U.S. Department of Commerce. And our mission is to promote innovation and industrial competitiveness in the United States through a combination of development of measurement science, of standards, and technology. So it's a very broad mission to serve all of U.S. industry. So we are the National Measurement Laboratory for the United States. We're responsible for the basis of essentially any kind of measurement that you do in commerce throughout society. We are a research organization, so we have a lot of close ties to academia, and we tend to focus our research efforts on things which are either measurement issues or specific technological problems that we think are barriers to advancement of industry. And we are involved in development of standards, and our staff at any given time are involved in something like 900 national and international standards committees. So it's a very broad sort of mandate. Now, I work in what's called the engineering laboratory, and I manage a research program and standards development program called Embedded Intelligence in Buildings. The basic concept behind that program is to try to take advantage of the opportunity to combine sensors and information that you can measure in a building or a home with networked computer controlled technology in order to improve the operation of buildings. So there are several aspects to how we can make that work. But the first part of it is how do you enable the sort of interconnection to give you those tools? So we've been involved in developing standards to do that in the commercial building space. The best example is something called Bathnet, which stands for Building Automation and Control Networks. We worked with industry partners to develop the standard, which is now an American national standard. It's a European community standard. It's a worldwide standard through the International Organization of Standardization, and it's been adopted as a national standard in about 30 different countries. In addition to this protocol that allows the integration, there's a companion standard recognized in all those same places, which is all about how do you test products to be sure that they actually conform to the standard. So the result of all that has been the creation of an environment where there are now over 800 companies around the world who make building automation products that use this technology. There are internationally recognized testing and certification processes to allow consumers to know that the products that they buy will actually work correctly in this environment. So we've created, and more than half of all building control systems sold in the world today use this technology. So we're beginning to see a penetration of this into the existing building market. So that creates an environment where we can get access to this information, and now what do we do with it? I'm sure you know from your own experiences, we don't have a great track record in the building industry of operating things well and maintaining comfort conditions well. So we're trying to address that in several ways. One is we have a project that focuses on commissioning of building systems. It's a combination of both improving the knowledge and the state of practice in the industry about how to do commissioning of building systems, but also we're looking at ways to use this technology to reduce some of the very labor-intensive aspects of that. If you have a large building, you might have over 1,000 devices that you might want to commission and be sure operate properly, and that's a difficult thing to do without some automated help. Related to that, we are also involved in some research and development related to what we call automated fault detection and diagnostics. We do this both in the large commercial building space, the kind of systems that you find there, but also we're doing work with heat pumps and air conditioners that are used in homes and in small commercial facilities. In both cases, the key concept is to collect the information that you have available from these systems and to do analysis of that data to try to find faults that have happened in equipment or operational difficulties that are either impacting energy consumption or have the potential to impact comfort conditions. We also, in the large buildings, we have a problem in that building systems interact in complex ways. So we would like to try to optimize these large systems by considering all that complexity. What happens today is that typically operators have sort of rules of thumb. They set things in places that didn't get them in trouble with the occupants of the buildings. but it's not always the most efficient way to do it. And so we're working on trying to develop intelligent agent technology that can understand the performance of various pieces of equipment and systems in a building, exchange information with peers in a distributed way, and come up to optimal or semi-optimal solutions on a building scale. So that's another aspect of what we're doing. And the closest tie to the subject that we've had here, which is also part of our program, is how can we interconnect these building systems with an emerging smart grid. NIST has a very broad mandate in the smart grid area. Congress gave us the challenge of trying to establish a standards infrastructure to enable smart grid. And at NIST, every laboratory at NIST is involved in this in one way or another. In my particular case, our involvement is in this area of integrating buildings and building systems with a smart grid. And I like to assert that we can't achieve the realization of a smart grid without smart homes and buildings. And you've heard a little bit of that in some of the comments made earlier today by our speakers. But the reason I say that is because that's where electricity gets used. 73% of electricity in the United States is consumed in homes or commercial buildings. If you consider industrial facilities, which are also largely buildings, you get most of the rest. So as we move to an environment where we're transitioning from a system where all these buildings are essentially a load at the end of a generation, distribution, transmission, I said that wrong, generation, transmission, distribution system, to something where they're also contributing to generation through local renewables or other kinds of generating facilities that they have. As we increase the use of renewable energy, whether it be grid scale energy or something that's building scale, we have to deal with the fluctuations that take place in the availability of those resources. Buildings become an opportunity to be a partner with the utility in addressing those issues, in moderating the consumption of energy in buildings in a smart way to match peaks and to match these renewable generations. So the work that we're doing is to try to create a standards infrastructure that helps us to do those kinds of things, to both enable the technology to advance and also to give options to policymakers of things that they might do.